All right, what we're going to go over today is called Doppler effect. So before we go into it, I'm going to give you an example of what the Doppler effect sounds like, and then we'll go into why that happens. Okay, so the Doppler effect is going to sound like this. So that change in pitch that you're hearing, that's what we have to be able to describe and explain what's going on. Okay. So before we go into that, I'm going to go ahead and go over some basics, some things that we need to know to understand this. Okay. So let's say we have a sound wave that's traveling on or traveling in air. Okay. If that sound wave is traveling in air, then the speed of this sound is going to be 340 meters per second. Okay, and that's always going to be true. So if my medium is air, in other words, if my medium is air, this would be my speed. However, if I change the medium, I'm going to actually change the speed of this. So for example, let's say I have another sound wave, right? But that sound wave is now in water. So if that sound wave is in water, what's going to end up happening is these waves can actually bump molecules quicker. So my speed ends up being a lot higher. So my speed would be around 1,400 meters per second. Okay, in this example, my medium is water. All right, the main thing I want you guys to get out of this is that if I keep my medium, it doesn't matter what type of sound wave it is. If my medium is air, this is always going to be my speed. Okay, so in other words, your speed only changes if you change the medium. But if you have the same medium, then you're going to have the same speed, or wave speed to be more specific, which we represent with V. Okay, same speed always gives the same medium always gives us the same wave speed. Okay, remember, wave speed is equal to lambda times frequency. Okay, so let's keep that in mind. So remember, this is a constant. It's going to stay the same if we are in the same medium. Okay, so let's go ahead and go into the Doppler effect. So the Doppler effect is going to be an increase or decrease in frequency of a wave as the sound source moves toward or away from each other. Okay, so let's take a look at a wave. Let's take a look at this non-moving sound source. If we look at this non-moving sound source, we're going to notice that this is non-moving. You're going to notice all the waves in the front and the back. So let's say this is beeping, it's making a sound. All the waves are evenly spaced. In other words, they all have the same wavelength, because this you can think about this as a crest, and this would be a crest. Okay, every single crest is equally spaced. Okay, however, when we have a moving sound source, that changes. The things are no longer evenly spaced because, well, if you notice in the front, the waves are more together. In other words, in the front, my wavelength goes down. It decreases because the waves are squished. Why? Because, well, the guy's driving this direction, so those waves that are coming out are squished in the front. In the back, because those waves are leaving the source, they have if you notice, larger wavelength. Okay? So we already explained that speed has to stay the same, right? So if speed is equal to wavelength times frequency, this has to stay the same because all these waves are traveling in air. That hasn't changed. So if my wavelength goes down, this has to be balanced by my frequency. So my frequency has to go up. Okay, in other words, here, when the wavelength goes down, my frequency goes up. Same thing here, or rather the opposite. Here, my wavelength goes up, so in order to keep the speed the same, my frequency has to go down. Frequency goes down. Okay? So that's why and how do we interpret frequency? Well, high frequency to us sounds like a high pitch. That's why when the car is coming towards you, you hear a high pitch. How do we interpret a low frequency? A low frequency would be a low pitch. Okay? So that's the main thing. And what you're doing for part of your assignment, there's a part where you have to do an illustration. You're going to be creating a moving sound source. It's really up to you, and the main things are you have to have a moving sound source. The waves have to be not evenly distributed because it's moving. So if it's moving this direction, the wave should be squished here. If it's moving in that direction, the wave should be squished in this way. Okay. Additionally, you have to explain how does the frequency and wavelength change at each part. So is the frequency smaller or is it greater on each part of the wave? Okay. Then you would go ahead and you would draw an individual. So for example, let's say I drew a moving sound source here. You would draw an individual and you would explain, what do they hear? Do they hear a high frequency or low frequency, and why? So don't forget to explain why. Okay.